Oil exploration is the process of searching for underground or underwater oil reserves. It involves various geological and technological methods to identify potential oil fields, drill for oil, and assess whether a site is commercially viable for extraction. This process is crucial for the global energy industry, as oil remains one of the primary sources of fuel and raw material for countless industries. The key steps in oil exploration include geological survey and research, where the objective is to locate potential oil reserves by understanding the geological conditions that typically hold oil. Methods such as seismic surveys, which create sound waves and measure how they travel through the earth, are commonly used. Magnetic and gravitational surveys measure variations in the Earth's magnetic and gravitational fields to detect subsurface structures likely to contain oil. Identifying potential oil traps is essential, as oil is usually found in sedimentary basins where organic matter has been buried, compressed, and transformed over millions of years into oil. Explorers look for geological formations known as oil traps, including anticlines, faults, and salt domes. Once potential oil-bearing formations are identified, exploratory wells, also called wildcat wells, are drilled to confirm the presence of oil. This drilling process involves boring deep into the Earth's crust to reach potential oil reservoirs and provides rock samples for analysis. If oil is found, the well is called a discovery well. Evaluating commercial viability follows, where even if oil is found, it must be determined if extracting it is economically feasible. This involves estimating the size of the oil reserve, its quality, and the ease of extraction. Costs related to extraction, infrastructure, and transportation are weighed against the market value of oil to decide whether to proceed with production. Appraisal drilling is conducted to get a more accurate assessment of the oil field size, with additional wells drilled around the discovery well to determine the boundaries of the oil reservoir. Once the oil field is deemed commercially viable, development and production begin, involving the construction of infrastructure such as pipelines and production wells. Production wells are drilled to start extracting the oil, and secondary recovery methods may be used to maintain pressure in the reservoir and increase extraction. There are two main types of oil exploration: onshore and offshore. Onshore oil exploration involves exploring reserves located on land, which is usually more accessible and cost-effective but raises environmental concerns. Offshore oil exploration targets oil fields beneath the ocean floor, requiring complex technology and incurring higher costs, but a significant portion of the world's oil reserves is found offshore. Environmental and social impacts of oil exploration include significant environmental risks, such as oil spills and habitat destruction, as well as contributions to climate change through greenhouse gas emissions. Economically, oil exploration can lead to growth and job creation, but it can also cause social and political challenges, including conflicts over resource control and economic inequality. Modern technologies in oil exploration include 3D seismic imaging, which improves the accuracy of locating oil reserves, enhanced oil recovery techniques to extract more oil from existing fields, and the use of digital technologies and AI to improve exploration efficiency. Remote sensing and satellite imagery help identify geological formations and monitor environmental impacts. Looking to the future, there is a shift toward cleaner energy sources as concerns over climate change grow. Some companies are diversifying into renewables, while others invest in carbon capture and storage. Unconventional oil exploration, such as fracking, has opened new possibilities, though it presents environmental challenges. As accessible onshore reserves dwindle, oil companies are increasingly exploring deepwater and Arctic regions, which pose technological challenges and higher environmental risks.